Lesson 3, I can solve for unknown angles and word problems and diagrams involving all learned angle facts. This is really just more practice from lesson 2, and note that it says all learned angle facts and angle relationships. So if we review those real quick, vertical angles are across from each other and they have equivalent values. So 1 and 1, 2 and 2, so 2 are the same, 1 are the same. Adjacent angles are angles directly next to each other. Complementary angles add up to 190 degrees, and supplementary angles add up to 180 degrees. There are also angles that create a circle, and those sums are 360 degrees. So let's go ahead and do the opening exercise on your notes. Two lines meet at a point that is also the vertex of an angle. The measures of angle AOF is 134 degrees. Set up and solve an equation. So again, we are setting up and solving equations. That's the key to these lessons, not just trying to figure them out and find the missing angles, but setting up equations to do so. And we are trying to find x and y. Let's do x first. And let's take a note at some of the relationships we have here on this diagram. First thing I note is that I have a sum of angles that add up to 134 degrees. Those angles include 14, x, and 90. 90 degrees is found here. So those three angles add up to 134, which creates an equation. I can combine like terms of 14 and 90 to make 104 plus x equals 134. Subtract the 104 from both sides, and lo and behold, we have x equals 30. Before you move on, just ask yourself, does 30 make sense? And it does. 30 is an acute angle, and it could very well be this measurement. Another way to check is simply add 14, 30, and 90, and those should add up to 134. Alright, now we've got half the problem done. Let's go ahead and take care of the next part. We need to find y here, and the one thing I notice is that this line here is 180 degrees. It's a straight line, so a sum that equals 180 degrees using the angle of 14, 30, 90, and y. So I have the equation that looks something like this. 14, 30, and 90 add up to 134 plus y equals 180. Subtract 134 from both sides, and y equals 46 degrees. Again, that's pretty logical that it could be 46 degrees. Alright, moving on to another problem. Set up and solve an equation to find the values of x. Well, we've got three angles, all of them in which add up to a circle, which is 360 degrees. We have a 90 degree angle. We have x, and we have 123. Combine like terms to get 213 plus x equals 360. Subtract 213 from both sides. X is 147. It is an obtuse angle. This is an obtuse angle, so it makes sense. Exercise 1. 5 rays meet at a common endpoint. In a complete sentence, describe the relevant angle relationships in the diagram. Set up and solve an equation. Again, I want to focus on setting up and solving an equation to find the value of A. Well, this again looks like something that adds up to 360 degrees. So I will make a sum of 360, and I'll just start naming off all of the angles. And this one may be a little tricky. I want to start with this 90 degree angle. Then I want to add this next piece, which I'll notate in a different color for you. I want to take care of this angle. And this angle is 90 degrees, but there's a section of it right here that's already been considered with this part of the 90. So I'm going to count that as 90 minus 21. 90 minus 21. It takes care of not duplicating this 21 degrees twice. Then we've got angle A, so plus A, and then plus 143. We'll squeeze this in here. Alright, just like everything else, we combine like terms. So there's a total of 302 degrees plus the missing A. All of it still adds up to 360 degrees. Subtract 302 from both sides. A equals 58 degrees. Example 2. 4 rays meet at a common endpoint. In a complete sentence, describe the relevant angle relationships in the diagram. Set up and solve an equation. To find the value of x, find the measures of, find the values of x, and then find the measures of BAC, which would be BAC, so this is x, BAC, and angle DAE, which would be this angle. Alright, so some relationships that we can notate, I believe again is going to be 360 degrees, because all of them add up to a total of 360 degrees. So let's put a sum, 360 equals, and we'll list all of our angles. We've got x, we've got 90 degrees, we've got 5x, and then we have 204. Combine like terms, we get x. No, we don't have just x, we have 6x plus 294, and all of that still totals to 360. Subtract 294 from both sides. 66 equals 6x. Divide both sides by 6. So we have 11 equals x. Now we have solved for x, but we have not answered these two questions here in regards to BAC and angle DAE. Angle BAC is simply just x, so angle BAC equals x, which therefore just equals 11 degrees. But angle DAE equals 5x, which equals 5 times 11, which therefore equals 55 degrees. Alright, moving on to exercise 2. 4 rays meet at a common endpoint in a complete sentence. Describe the relevant angle relationships in the diagram. Set up and solve equations. Find the value of x. Find the measures of angle CAD. CAD would be this angle here, and its value is 3x. Alright, looks like once again they all add up to 360 degrees. I'll go through this one quickly because I feel like this is repetitious. 360 equals, we've got 12x, 3x, 60, and 90. Simplify, combining like terms, we've got a total of 15x and 150 degrees. Subtract 150 from both sides. 210, 15x divided by 15. So we have 14 equals x. That is only part 1 of the question. Part 2 is to find angles CAD, which equals 3x, which equals 3 times 14, which therefore equals 42 degrees. Moving on. Example 3. 2 lines meet at a point that is also the endpoint of 2 rays. In a complete sentence, describe the angle relationship. Okay, set up and solve an equation. In this case, we're not going to be able to use the 360 degrees, but if we notate that there's a straight line that adds up to 180 degrees involving these three angles. Angle 1, angle 2, and angle 3. Now we don't know either of these three angles, any of these three angles. However, there is something we can logically use to find out. We know that this angle is 90 degrees. We know that EH is a straight line. So therefore we also know that this is a 90-degree angle. And if this is a 90 degrees and this is 30, then we know that angle 1 is 60 degrees. Now we know that the sum of this line, I'll change back to purple so you know we're talking about the purple line. The sum of this purple line is 180 degrees, and those three angles are 60, 3x, and 5x. So combine like terms, we have 8x. Subtract 60 from both sides to get 120 equals 8x. Divide by 8, x equals 15. Now for the sake of time on this video, I'll go ahead and let you figure out the two missing angles of BAC and BAH. It's just a matter of plugging that 15 in for x in both cases. Lines AB and EF meet at a point which is also the endpoint of two rays. In a complete sentence, describe the relevant angle relationship, set up and solve the equation. We need to find the value of x and find these two angles. I'm also going to notice that there's a straight line here because it is a line EF, so we know it's a straight line. We know it's 180 degrees. And that line is made up of several different angles. We could go two different routes. We could go, well, the only route that's going to help us with finding x is if we use this side here. So I know that I have x, 5x, and you might say we don't know this angle. However, going back again to the last problem, this is 90 degrees. 42 subtracted from 90 would be 48. We combine like terms. 180 equals 6x plus 48. No. 90 minus 42, yeah, is 48. 180 minus 48, subtracting 48 from both sides, 132 equals 6x divided by 6. 22 equals x. And again, for the sake of time, I'll let you figure out what these two are just by taking 22 and plugging them in for x. Two lines meet at a point. Set up an equation to solve. Here, something a little different. We have two vertical angles. Remember that definition of vertical angles, angles that are directly across from each other. Those angles are equivalent. So I know that 3x and x plus 30 are equal. So 3x equals x plus 30. And from here, it's just an algebraic equation we can solve. I'm going to subtract x from both sides, which leaves me with 2x equals 30. Divide by 2, x equals 15. With x equaling 15, we can multiply that by 3 to get this angle, and just add 30 to get this angle. Last problem is very similar. You're going to set up two vertical angles that are across from each other, and they are equal. So x plus 54 equals 4x. All you have to do is solve for x. That should be enough to help you out with lesson 3.